Ever wondered why a perfect model isn't always the best solution in data science? Today, the spotlight shines on a phenomenon known as overfitting. Now, don't let the term intimidate you. It's just a fancy way of saying that a model is trying too hard. Imagine a student who has studied for a test by memorizing every single question and answer from the textbook. They ace the test based on the textbook, but when presented with new yet related questions, they struggle. This is because they've overfitted their study to the textbook. They've learned the specific questions and answers, but not the underlying principles or concepts. Now, transfer this scenario to data science. A model overfits when it performs exceptionally well on the training data but poorly on new, unseen data. It's like our student who aced the textbook questions. The model has learned the training data too well, including its noise and outliers, and fails to generalize on new data. Building a model is like walking a tightrope. On one side, there's underfitting, where the model is too simple to capture the patterns in the data. On the other side, there's overfitting, where the model is so complex that it starts to capture the noise in the data. Striking a balance is key. So how can one detect overfitting? The first sign is a large gap between the training accuracy and the test accuracy. High training accuracy and low test accuracy often mean the model has overfitted the training data. Another way is through cross-validation. By splitting the data into a training set and a validation set, it becomes possible to check how well the model performs on unseen data during the training process. Now, the question arises, how to prevent overfitting? There are several techniques like regularization, where the complexity of the model is limited, pruning, where parts of the model that add little value are removed, and early stopping, where training stops when the model starts to learn the noise in the data. Remember, the goal of a model isn't to memorize the training data, but to learn from it and generalize this learning to new data. So in summary, overfitting happens when a model learns the training data too well, to the point of picking up on its noise and outliers. This leads to poor performance on new, unseen data. It can be detected by a large gap between training and testing accuracy, and prevented by techniques such as regularization, pruning, and early stopping. Never forget, a perfect model isn't the goal. A model that can accurately predict new data, now that's the golden ticket in data science.